Hey everybody, this is Larry. This is day 30th of the Leetcode Day Challenge. Oh man, there's something in my eye. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's problem. And today we're giving a hard problem, hopefully not too hard. Not gonna lie, I'm a little bit tired just because I was playing around with the stock market this morning and did not do well. Let's just put it that way. Even though it ended up being mostly flat, so it's kind of crazy. I don't know. Just having a bad day with respect to that. It's been a weird month. I feel like nothing's been going right this month, but it's okay. You know, it's not a small sum of money, but at least it doesn't change my life, so that's okay for now. I mean, if it happens a couple more times, maybe it will. So I don't know. But anyway, let me know in the comments your craziest trading story. Maybe I'll share it, but I don't think it's that interesting. Just that like I did some stuff and it went down. I don't know. I didn't even touch gold or silver. Is anyone gold and silver? Let me know in the comments as well. I'm kind of like I don't know, too much of a boomer to have been up on it. Like, why is everything up so much? I don't get it. Anyway, okay. Rant aside, unrelated rant aside, let's take a look at today's problem. And yeah, let's do it. Today we have 2977 minimum cost to convert string 2. Alright, you come in 2 strings, source. Oh yeah, this is like the harder version of yesterday's, right? But what did they change such that is different? Like what did they change about this? I mean, you still have original to change. One operation, you can do it. There's a cost thing, but any pairs. Oh, there's 2 conditions. The string picked in the operations are source A to what? What does that mean? Does substring pick an operation? Oh wait, what? Oh, you in one operation you may pick a substring. I see. Okay, so then you're allowed any number of operations, but it has to be in 2 of these things. Okay, I see. So it's a substring, not just a character. So that's what's different. I mean, it seems like it's a different problem with. Yeah, I mean, there's some overlap, but not much in arithmetic. Probably not. Okay, so the indices are disjoint. B is So okay, so you have basically 2 segment because B is less than C or D is less than A. But I mean that just means that without loss of well maybe it does because it depends on the source. But yeah, okay. So okay, there's no overlap, right? So okay, so either choose 2 substrings. Wait, what? If there exists any index J such that, okay, I mean, yeah. Is this for or J? That's what I'm trying to think. Substring, I guess these are now substrings. I see. Yeah, okay. So for some reason, I was still thinking about characters from yesterday's problem. So I was like, do they mean like for every character? Okay, no, it just means substring. So I see. And then okay, and then now the substring. Okay, so either the substrings are disjoint. Wait, how does that? What does ABCD mean in this case? Huh? Like, why are there 2 substrings? I thought there's only 1 substring. Man, I cannot read it today. I'm so confused. I mean, I guess I'll have to look at a thing, but do they mean destination? I don't get it. What is source? Like, where does the ABCD come from? All right, let's take a look. Okay, but that's like 1 substring, right? So, I see. I messed up. So any pair of operations. So okay, so they have to be. So basically, you have to either you take a substring and you either do that substring multiple times because they have to be identical, or all of them have to be disjoint. So they have to have no overlap. So you can't even do like a substring, if you will. So okay, So that means, I think the first thing I would do about these problems is look at the constraints to kind of figure out. It took me a while to understand this problem, to be honest. Maybe my brain is not working today because, but now the first thing I want to look at is the constraint, and the constraint is going to be 1,000. Okay, that makes it more tractable, possibly. The number of things are 100. Maybe that's interesting, but I don't know, right? Yeah, I think this is fine. I don't know. You could just put a lookup anyway. But the 1,000 makes it interesting because then now you could do, at least my first idea when I see 1,000 is that I can do some kind of n square stuff. And one of the n square stuff that we might consider is, just slicing off the prefix, right? But if you don't do it carefully, it can certainly be, it can definitely get sketchy. I think one thing that I sometimes do, but I don't do enough, and for now, or like at this moment when I'm talking, I am solving this live. I do not quite know how to do it. I have some ideas of attack, and I have some ideas to kind of play around with, but I don't know definitively, like confidently, what the answer is. I just want to give that out there because sometimes in these videos, honestly, most videos by now, I actually know the answer. I'm just thinking about how to explain it, right? Because it is just what it is. But this one, like I have some ideas, but I have to think about it. Or like I have to play around with some constants because you don't want to end up with like 1,000 million thing, right? Or 100 million. I think 100 million is fine. It's the number. It's not fine, but okay. Because a way and I think one thing that I do sometimes, but I don't always, is that for me, code is actually visualization. For a lot of people, especially if you're starting out or even a little bit more, that might not be the case for you, and I understand that. But for me, because I've done it so much, that code sometimes is visualization. And why do I say it that way? Is that for me, especially certain types of DP. It's not, I don't need visualization on code or code type of visualization on all types of problem. But for me, writing out the DP sometimes allows me to see, okay, this is how I want to optimize it, right? Yeah. There's some like possibly cheesy answers or like solutions as well that I'm thinking about that may be fast enough just because this is Python, but But we won't rely on that just yet. Okay, so what I wanted to do now, and I kind of alluded to a little bit, is that I want to write the crappy naive E solution. It's still like a little bit tricky if you haven't done it before, but naive-ish solution that I'm gonna go over. And it probably or shouldn't be, if you ask me, be fast enough, but we'll see. One thing I would also say is that if it isn't clear by now, this is a well, I don't know if the end result is a dynamic programming, but for me, I'm going to tackle a dynamic program solution. I'm not explaining in much detail because honestly, for now, I am not confident on how I want to do it yet. And these videos are live, right? So, but what I want to say about that is that, I might not go over the details of DP as a result. So, so take this as a time to maybe pause and dynamic programming is a prerequisite, at least for this portion of the video. So, if you feel like, you want to work on another problem, shore that up and then come back, let me know. But yeah, or you don't have to let me know, I'm just saying. Okay, so let's say we have an f function with an index, right? This assumes, right, that the first, you can write this in different ways. In terms of trying to understand it, and I write this different sometimes, and I write something like the first index of source is or matches target, right? The first I mean index of sort, not like the first index isn't, you know. So then now maybe write something like if index is equal to n, then we just return 0 because we have no cost, right? And then maybe even like a very simple thing of like if actually this is not necessarily true. So maybe I was going to write something like if source of index is equal to target of index, then you can just return f of index plus 1. But that's actually not true because in DP, you know, you want to take the max, the optimal, and that might not be optimal. We're trying to minimize, right? So yeah. So then you may need to want to do something just like this, right? And then now the naive part, and there are a couple of ways you can do it, and there's some like very basic optimizations, but the most naive way that you could write it is that if maybe source and you still should maybe use Floyd Warshaw or something like this, but yeah, maybe we will. Maybe that makes it fast actually. Maybe. Because maybe that filters it out enough. I don't know that that's true though, because they could be just all the same character or something, and maybe that makes it slow. Because then now, yeah, I think you can construct a case very easy that makes it slow. If they're all like A, and target is like B, and then you have like, you know, various and like just one character things, and then that you can force it to match every time, and then it becomes like an n cube type, or 1,000 times 1,000 times, I don't know, 100, I suppose. Well, no, this would be another 1,000 actually, right? Yeah, because you can. Well, no, it could be only up to 100 because we can only have 100 things. Okay, but I was going to say something like, okay, maybe you could write like there are different ways to write this, but maybe you can write something like even writing naive one is kind of annoying actually. Like maybe you could just write like like just do the most naive thing would be the change list, right? So original changed costs in zip, right? So then maybe you can write something like now, I mean, this would never work, so I don't know. But you could, maybe I'll just write in pseudocode because you still need to do some pre-processing, which we should do anyway. So I would consider doing it. But just like, I don't know, convert the index to convert some prefix of the string source to target. And then that will get, and there'll be multiple of these, and then that'll give you some idea of something like f of index plus length plus the cost of I or whatever, right, for some I. And then so that's kind of the pseudocode. It's not, obviously it's not real code. I mean, and it wouldn't be fast enough even if I wrote it out, and I don't, and at some point I just need the visualization, so I don't want to write it out for no reason, right? One thing that is clear is that we should use we should pre-process this, right? Because you want to do the same idea that we had yesterday of like, well, if you want to go from A to C, but maybe A to B to C is cheaper, right? But you also just want to process that maybe sometimes it's just not like maybe there's no way to get to C without going A to B to C, so you need the shortest path thing anyway. We're gonna do it with Floyd Warshaw because it's easy. Also, I just remember like randomly what I was trying to remember yesterday that I couldn't remember for the life of me. But it's Bellman-Ford. I was thinking about Bellman-Ford in case you're watching from yesterday. I don't know. Or like you watched yesterday and you're like, what is Larry talking about? Anyway, but it's unrelated and doesn't matter anyway. But yeah, but for this one, okay, so then maybe I would just write, how do I want to write this? because I don't want to just write 3 arrays. I mean, that's fine, but I want to do like length sensitive ones because, you know, because the nodes are not the 100, right? I mean, there are 100 nodes, but the nodes are actually, well, O and C and stuff. And they are basically on an island. What I'm trying to do now, honestly, is try to remember how to write Floyd Warshore. Because there is a sparse version of Floyd Warshore, but I'm trying to remember what the right way or the clean way to write it is. I mean, we'll work it out anyway, but yeah. So, okay, so let's just say we have yeah, okay. I mean, let's just say we have names as equal to right? And then now we have distance is equal to and that has a collections of default text or counter, I guess. No, counter has a default 0, right? So we want something like this where it has like an infinity, so we don't try to do it. Does that work? I always forget the exact syntax of this thing because it may call it. Yeah, okay. I mean, it's not a major thing. I just forget whether I need to use this because I guess technically if I didn't have this thing it would work, but it's I kind of knew that, but I was hoping, I suppose. Okay. Okay, yeah. So then now we have and assume that these have the same length because that would just be awkward if it's not. Okay, that is true. Then yeah. L is equal. We use big L is equal to length of O, right? And then names of L dot append O and C. Though this should be a set. No, it should be a map, right? So then we can write. I mean, okay. So if O is not in L, then names of length of names is equal to O, or the other way around. Whoops. I don't know what I want to do. Oh, what the 9 names? And also, if it's not super clear, no, that's not what I want to do. What am I doing? Okay, so I guess what I actually want is a map, right? Is it map? Or text? Sorry, wrong language. Okay. Right. So then now we do this, and then we can say D is equal to name sub L, right? And then now it's on D. Right, so something like that. It's just so that we can have things to kind of think about or CO, right? Right, and then we can just audit it, right? D is the names. Wait, is it? Oh no, you don't. I mean, D is probably fine, but that's not what I'm looking for. I was really confused. Okay, so this is fine probably, and then this is probably fine for cost, and then now we can do a dice drift for whatever, right? So then for L in range of names or range in names dot keys, right? Yeah, names dot keys. Then now we want to do for K in names of L dot Okay, let's just write D is equal to I mean, it ends up being not sparse anyway. Anyway, the way that I'm writing it. But okay. So then now this is necessary. Yeah, I guess so. But I also need something. This is so annoying already. What, am I doing something crazy? That's what I'm trying to think. Maybe I am, but I also need a list. How many things do I need? Man, do I suck at programming? Probably. But No, I think this is right. I think I just need, oh, this is fine, maybe? Maybe I'm wrong, I don't know. I think I just need this. Even though in this case, then I just need a list, except for it allows me to do this in all of one, which is why I did that way. But yeah, then now, we can say maybe M for max is equal to length of D. Then now for K in range of M for, right? And this is regular for Warsaw. You may wonder why, if this is already M cubed and M is 100, then doesn't make it L slower. The answer is not actually, because it's the summation of things, right? This is the standard amortization things. Because, for example, if M is 100, then L has to be 1, right? If M is 50, well, then 50 cubed is already 8 times more than 100 cubed. But then L has to be 2, or it doesn't have to be 2, but like, if you want to distribute it that way. So so then we 2 times M over 8, so there'll be like M over 4 or something. So the max case is still M cubed. We could do things that way. In case you're wondering. But yeah, but otherwise, then now we just do distance of, in this part, I'm not, actually, maybe I should. No, because I needed to differentiate the L's. I mean, maybe I could put another level here, but I don't know. Maybe this is fine. I don't know. We'll see. This part actually may not be as performant, because now we're doing, like, even though this is a tight whatever, this part is not very performant. So we'll see. But for now, we'll just keep it dumb. Yeah, and this is the same as before, right? As you imagine, it's going to be min of this ij, this ik plus this kj. But maybe we want to verify that if well, it's not ij. It's going to be that's why I got confused. But yeah, if d sub I is, because this one, I guess it could construct from nothing. So this has to be, I guess that's what I would write, right? So maybe if this is not infinity and this is not infinity, then we do this. I don't know if that's that much better, to be honest. But maybe we also convert it to like name I is equal to d sub I, name j is equal to d sub j, and k is equal to except for that, we want to put it closer so we don't keep on initiating, right? So then now you can do something like that. But yeah, hopefully, I mean, I know that I'm doing this very slowly, but this is actually like, obviously a little bit different from quote unquote the template. But hopefully that gives you an idea of like how I kind of think about things. Like I don't, like I don't memorize this obviously necessarily, but I'm just trying to think through first principles and how to think about it, right? But yeah, and then now this should be good, right? In theory. So we can try to print something really quickly, right? Like for example, there's nothing from A to, I also have to double check that. Yeah, this thing, because that's where I got a wrong answer yesterday, right? So this, we have to go to. I mean, that's all I need, but I mean, I didn't do it yesterday. So yeah, we can also check. I just say A to E because we don't have anything direct. If not if the Floyd ratio is correct, this should give me a non-zero answer. I should, like 22 maybe. Maybe just oh no, where did I print this? Oh, actually it's 8. Is 8 right? Maybe it's 8. I just saw A to B and then oh no, that's a D. 8 is possibly right. I mean, A to B to C to E maybe. So maybe that's right. But yeah, but that's why I wanted to show. I mean, because if it was infinity, then it's just, well, something's not working. I mean, it still may be wrong, right? But yeah. But basically now, I mean, there are a couple of ways I'm thinking about, right? I mean, there is the obvious prefix tree pre-processing. And maybe that'll be fast enough. Though I don't think that helps me with respect to, in the worst case of, if all the characters are the same and they all exist, then the prefix tree doesn't really help. Oh, sorry, I guess the try doesn't help, which is a prefix tree, I guess. I'm just confused today. So how can I, like, if I were just to optimize this DP, right, then I need to, actually, no, Larry, you're wrong. For some reason, I thought there was a for loop in here and then another for loop. I can't do a for loop. It's okay, Larry. Yeah, why am I so crazy? Okay, because then now, yeah, we can just do something like, and you could probably use a prefix tree, but I'm going to keep it dumb for now. For some reason, I got confused about my analysis, So, okay, so actually, no, we don't. This is why I need to visualize it sometimes, because I just forgot. But then I'm able to see this. I'm like, no, Larry. You could just add a for loop here. This is O of n. You add an O of n for loop. If you keep the comparisons cheap, which we won't for now, then that should be fine. And if we had a prefix tree, then we can keep some of the comparison cheap, right? And in this case, what you would want is a double tree, right? Or like a try in which you have both the source and the target on the edge, right? So then that would make things really fast. I was going to write it without it, but, and this just came up to me, by the way, in case you're wondering. I'm saying that because sometimes it does look like, like how long, because in a lot of videos you may wonder, like, oh, is Larry just like waiting for now to explain it, or like does it just come over now? And no, I mean, prefix tree is obviously an idea that I just I had, because you're trying to get we're doing this with prefix. But the thing that I missed initially is that it's fine to have a for loop here. That's one, right? Because for some reason maybe I confused the states a little bit for index. That's my fault. But yeah, it's fine to do a prefix try. Or it's fine to have a for loop. But I was thinking about, like, okay, well, I mean, you can do some stuff or whatever, but then what just came up to me is not the prefix tree by itself, but combining it, having both these indexes, if you will, or whatever, as an edge to the prefix tree. And that, of course, means that we have to pre-process the distance thing, which is fine. But because that also means that we don't even really need this. I mean, we needed to calculate it, but that's fine. Right, and maybe there's some optimization here, which is, like I'm trying to walk through the process, right? So yeah. So then in theory, if we have a prefix tree, and we'll write out whatever, right? prefix tree is equal to the root node, right? Let's just say root, right? So then now we have for j in range from index to n, right? So then now we walk the prefix tree, right? So if current dot edges, maybe I'll be a little bit lazy. I'll write like I won't have an API thing because this is already too slow, I think. If this is the case, then we do current is equal to current dot edges of source index, something like this, right? And of course, but before you want to pre-process this, right? So here you may do something like, well, we match on the up to index, so we want to go index. Oh no, not index, but we want to go. Oh, I mean this is all wrong anyway because I confused it. But this is this is one issue about naming things index is that you think everything's an index. This happens to me a lot also. Okay, so you go j, you're j in. That means that you're done with j. So then you so then you can mean that you can do min of this plus the cost that is at the current. Well, is this after we travel? Yeah. So this is or do we put on the edge? No, we can't really put on an edge. So we would say, so this is after we travel. And when I say after we travel, I mean like going to the node. And I'm trying to think through right now, for example, on the prefix tree, on the try, where to store the distances from, you know, right? And I'll draw a diagram. Actually, let me do it now. I mean, I'm kind of like, I hope I don't lose my train of thought because that is definitely a risk. But the reason why I haven't been drawing is because, like I said, I'm solving this live, so it's not like I'm, you know, shy of drawing, but I just wasn't sure, right? But now I think I'm more confident and sure. I mean, maybe there's some micro optimizations I have to make, but I think the general picture I have a good idea of, right? So you have a root node, this is a try, and in a traditional try, you have like, you know, a regular whatever, right? But here instead, we have in character pairs, right? So maybe you have A, B. This is the cost of changing A to B on the next character, on the first character specifically, B to C, right, and so forth, right, and maybe like A to K, I don't know. And I was just thinking like, well, where do we store the remember this is on, I drew it a little bit poorly, but this is on the edge, right? This is on the edge, so then the node would actually store the value. And I was just thinking like, oh, would I store the value like maybe here on the edge, or just like this node itself, right? And I think this node itself kind of makes sense because, you know, then it's, but then as a result of that, then you have to travel to the next node first and then get the value, right? I mean, we can also not. Did I not show it? Oh man! All right, give me a second. Let me do it. Did I not show it? Huh? All right, let me. Okay. Sorry, friends. I mean, this is why I've been trying to do it live. I'll say it everything again. So if I did show it, then fast forward. You know. My apologies. But yeah, so in a traditional try, right? You have like a standard ABC, right? It just goes to the next node. What I was saying is that, okay, in this case, well, first of all, we want to do pairs, right? Because this is the cost of A going to B, C going to D, A going to E, say, right? And then, of course, actually, let me draw one more. So maybe this is, even if you did watch it, this is a little bit clarifying. And then this is B to C, right? Maybe. But this, of course, this node means that we change from A to B on the first character, B to C on the second character, or in other words, A, B to C to B of C, right? And then maybe you store the value there. And that's basically the idea. Of course, there are some caveats with implementing this, right? Or not caveats, just edge cases to think about. For example, maybe we have A to B, but this doesn't exist, but ABC is in the map, right? Or something, right? Well, I mean, that's fine. That's not so hard, right? But we just have to think about, because, well, technically this is on the edge, like I said, but we just have to like add another Boolean value of like whether there's a value here, for example. But, you know, but these are like, at this point, to be frank, those are very classic try prefix tree try-ish problems. I'm not like, you know, it's not the thing of it. But I just wanted to kind of talk about it a little bit, and this is why I have something like here. But yeah, but for me, like, yeah, you know, knowing the tools in your tool shed and me understanding prefix, and as I say from yesterday, I'm not saying it to brag, but I'm just saying it to in terms of like these are what's required for you to kind of, you know, have an idea of trying to replicate what I'm doing, kind of thing, right? But yeah, so then now we have like maybe a current, I don't know, has distance, I don't know, right? And this is a Boolean value that's stored on the node. Then now we just distance, something like this, right? I mean, you can name things probably a little bit better and stuff like that, but I think that's basically it. And then now we just have to return f of 0, and we have to do the memorization, don't forget, Larry, of just adding this, if I could type it correctly, which apparently is the hard part, just caching this, and we are basically done. Of course, now we have to do the try, we have to process the try with this, right? So, yeah, so maybe we would write something like root is equal to, just node is fine, right? And then we have, I guess we'll just replicate what we kind of wrote, which, actually, no. I mean, maybe, but we don't have to. We could just put it in here, right? So then now for every L, there's some like weird indenting going on. Huh. Okay, so then now, you know, after this, distance is done, or void for sure for L is done. So then you could just write like for I in range of M, for J in range of M, if distance of Ni, I mean, we have to, I know we have to re-index it, but and J is not infinity, then we have like root dot add, the reason why I'm pausing is that maybe this should be a helper, so maybe just by like add root Ni and J, distant Ni and J, right? Can I type though? And that's basically the idea, right? And we do the same thing there, except for type correctly. Oh my. Okay, right? Yeah, and then that's basically and then that's the only thing we have left to do, right? Maybe, could be wrong, honestly. And then now we have like def add, well, we have to put the node code, right? And node code is straightforward. Maybe we would, if speed is an issue, we might have to inline it, but that's fine for now. You know, initialization, we have, what do we have? We have, I guess maybe that's fine. Maybe we could just do this. We have, what do I call, has distance is equal to force. Distance is equal to none, let's just say. Yeah, none is fine. I mean, in theory, you don't even need both if you're going to use none, but it's cleaner slightly, maybe, right? So then so this is pretty straightforward though. Just a lookup, right? Yeah, and then now, as we said, we have node. In this case, it's going to be, I guess it's always going to be root, but okay, whatever. We have O for original, change for C for changed, and then distance for distance. Okay, right, and this is standard try stuff, right? So current is equal to root, right? For naming things is so hard. A, B, in zip of OC, right? We want to say, yeah, so current dot edges, right? So if AB in then current is equal to and maybe I should write this a little bit differently, right? Is that we always want to traverse, so if this is not in there, then we just create a new edge, right? So current dot edges of AB is equal to new node, right? I don't think I have to define anything, right? No? Okay. So yeah, so that's basically the idea. And then at the very end, then we will traverse everything. So then current dot has distance is equal to true. Current dot, I think we should only properly everything only once, so I think this is fine, right? Like we don't have to do a min like here because we've already, you know, propagated that out. And that's basically it, really. This should maybe work. I mean, I may have mistakes and stuff, but I don't know why the indent is all weird somewhere. Like, did I? Oh no. Oh, this is from my silliness. Okay. All right. I forgot that there's a -1, right? Okay, so that's fine, right? Yeah, looks okay. I mean, there is some concerns about performance, but I am lazy, and the complexity should be fine, right? Because this is the O of n space. This is an O of n loop. Each of the loop does O of 1, so this is n squared, which should be fine. There is some constant type optimization that maybe we can do, so we'll see. But the structure, I don't, I mean, I'm okay with it. Like, if we get timeout, we'll just make some optimizations, but I think there should be correctness. I mean, of course, we can make silly mistakes as well, right? So, like, apparently we have here, but the structure and the idea, I think I'm where I want to be, but apparently maybe I have some mistakes, so we'll see. This should be -1, but did I miss something? Because if this is not possible, then we just don't do best, right? So, because now I'm debugging, right? And debugging, it really depends on what you like. Because here it's saying that it expects it to be not possible, but we are making it possible, which is a little bit weird, right? So that's why. But that means that I am making something that cannot be possible, which means that like, I'm drawing an edge with the distance possibly where I should not. I think one thing that I made a mistake on is that that you can always don't change anything, but I don't think that that should be relevant. Okay, so a is nothing. So they say it's impossible. So, and this is a lot. So, but they're all single characters. So in theory, it's easier to debug. So I'm just like manually going like, okay, which one of these is not possible? A to A seems possible, right? A to B is directly in there. H to H, HA, HA. Oh, there's no. Oh, huh. No. Did I screw something up? Original to. Because so basically, what's wrong is that H to H should be fine, but H to A should be mixed in and impossible. But I have something here that is wrong. So, whatever. I just point it out. Because I mean, clearly, then now I know that something's wrong in the distance somewhere, right? Because it is saying that you can get from H to somewhere else. Or maybe not. Maybe I just have a typo. Because here, the distance seems okay, right? But that was my first attack. But now that we ruled it out, that means that the distance seems to be correct, which is thankful. Because I'm like, that doesn't look like incorrect. And maybe something was wrong in here. Or either that or here. Did I doesn't seem like that there's too wrong with this one, right? So did I OCD? I just noticed that I did OCD. Maybe I do have OCD, who knows? Okay, so we don't do anything here. So then how can you go? How can you go? Right? Yeah, no, I mean, this is one thing, right? So, am I off by 1 or something? Oh, I'm just dumb. Okay, I see. I actually did this is a risk, honestly, and I said this before, and it is actually 100% true. Like, I'm not even, maybe you think that I'm just trying to save face and but I was thinking about this when I write it out, but I totally just forgot when I was writing out because I'm always explaining things, and then as I'm explaining things, I just forget other things. And here I do remember having a mental note of like just breaking, right? Because this means that there's no edge, then you have to end, and then okay. I mean, a very silly mistake, but basically, if the try ends with no edge there, then you have to break, right? You don't keep going, and that's what it was doing. It was just skipping it, but then kept going. So yeah, that was just silly, right? I mean, time limit is more expected, but still no bueno, obviously. And we're not even close. I mean, this is just annoying. I mean, because complexity-wise, I think we're okay. And you can even see that if we just put this input case by itself, it is okay. It's just that, like it's not even that slow. It's not even hitting 1 second for this case of, I presume, max input. But it is what it is. So it's possibly, I don't know. There's some. This is just annoying. Did I do it in Python? I guess I did do it in Python. I'm just lazy, to be honest, today. There's nothing about it. In terms of like wanting to do more optimizations. I mean, tuple hashing is kind of slow. That's a possible thing. So maybe we can do some. I guess I don't need a tuple hash. Maybe this is enough because they are strings. I forget. I mean, there's characters, but they're also strings. I don't know if this makes it fast. This should make it faster, but whether it makes it a lot faster or enough faster, I don't know. Okay. Again, no guarantees. This actually turns out to be slower, so maybe we will roll it back. But but now, like I said, like the complexity is going to be optimal anyway. But as far as I think, but yeah. Okay, so this does look slower though. So maybe I'm going to submit just for the people at home for science. But normally I would be like, okay, maybe this is not going to be faster. We have 492 here, right? But this is just annoying for me too. But that's okay. I really thought that would be faster though. Oh, I guess maybe not that much faster or slower. We could do the fmin thing, right? Maybe that this one is the thing, right? Again, also annoying, but oh snap! I have to do my Duolingo. I have like 30 minutes to do my Duolingo. This is a little bit faster. I don't know if it's gonna be fast enough. We'll YOLO again. 35 minutes should be enough time, right? Unless I forget in the next after I finish. I don't know. Oh man, that's even slower. That is actually surprising. Am I messing? No, I mean, sometimes I try to think, right, how to try to think whether like what component is the slowest part. But yeah, but that may be just this part though. So maybe we'll change it back to tuple. Where's this part? Okay, but now we're going to change it to fmin. We already wrote it. Why not keep it? For sure, that is faster. It's just annoying, but I don't know why sometimes it comes up on the left and sometimes it comes up on the right. But I mean, it is clear that like if it's faster, it's not faster by enough, right? Am I messing something up on the complexity? Doesn't seem like I can optimize this that much more. Like maybe you could say there's some stuff about it doesn't budge. Am I missing something about complexity? There's the cache. Fort Washoe is probably the risky one, maybe. How long does it take again? This is where, like, you try to measure as much as you can, though sometimes it's not direct because, well, like, because, for example, if you do that, then this part of the code does nothing, right? But as you can see, like, the timing is still kind of high, so that doesn't seem like that's the reason. Then what is the reason? Or at least not only the reason, right? Is this the reason? Maybe the Fort Washoe is too slow then. Okay. I mean, it is what it is. Again, that might not be the only reason, because now that we don't have this, the rest of the code is much faster, right? So actually, let me order that, right? So then let's say we have this. We have much faster, like on the order of 20 micros. Is it micros or minis? No, it's milli, right? That doesn't make sense if it's micro. Yeah, and then maybe I do something like this. Oops. So you can see that just the for loop without the thing costs a good amount of time. So then we might have to cut it down, and that's fine. Then now, I mean, I was doing Fort Washoe just because I was lazy, but clearly it took a lot of effort to do this anyway. So so here maybe we write yeah, I mean, we just converted to a traditional all pairs shortest path. It is what it is. The reason being that in theory it does fewer map lookups. I don't know actually, but yeah, okay, fine. Right, and then now maybe we just don't care about these things anymore. Maybe we'll have to rewrite it in a different way. Maybe just we'll keep the distance one. We'll see if this is faster, but this is a little bit weird though. Maybe. Oh, that's it, right? Is Daisho faster? It shouldn't be faster though. I'm kind of confused, maybe a little bit. But I guess it's fine. I'll keep that in. I mean, not in the final version, but right. So then now, well, I guess we only add O, because if it's not the original, then there's no source, right? So then now we do for start and names, we just BFS, right? I was thinking maybe there's a way you can like optimize this, but I think maybe that's not important for now. And I lied, this is not BFS. I keep thinking BFS because I was thinking about things, but this is shortest, right? Yeah, this is going to shadow. Right, I just write T then. Why do I quit start? I usually quit start. I don't know why. sorry, right now I'm just implementing Dijkstra. I'm not doing anything super interesting. If you watch my videos from the last couple of days, you've seen me have done Dijkstra, hopefully. So, actually, I don't remember anymore. But most of my computer's a little slow. What is going on? Just closing some of my things. Okay. Yeah, I already used D and distance, so yeah, whatever. Yes, 90 or right? Yep. And then now, actually, I don't even need this. Because I don't use it for anything, right? What I need is quarter result, right? And then we can do all for key value in all dot items, the distances from whatever, right? So then add root start key value, and I think that's it, right? And now we can do all this. We'll see if it's faster. It looks much faster, right? So let's give it a quick spin. Maybe I was just trying to do the Floyd Warshaw because I do love Floyd Warshaw, like I was talking about it yesterday. So yeah, so much faster. Maybe I should have done it, like I said, maybe I should have done it this way. But complexity-wise, it should be fast enough. But maybe well, especially the way that I was doing it with string lookups and stuff like that. Maybe there's just a high constant, and that stuff is just going to happen. What did I do last time? A lot of the time, limit exceeder was just me showing you. Oh, I guess I did do. Nope. Wait. No, I did do Dijkstra last time, and I even quite sure this. But I did do the lookup, huh? Did I not? Huh? I didn't do the try last time. It was fast enough, so maybe the try didn't really do anything. I mean, I actually kind of alluded to it earlier in the video, where I was like, you probably could get away with start with, because start with is way fast in Python because it's implemented in C and so forth. It's a very fast operation comparatively, and you can maybe even see me do this, but that's annoying. So I mean, that's half cheating. And during the contest is fine because you just do whatever. But when you do something like this, I also had in mind like, okay, there's also a chance that it may fail, and if it fails, then I would have to do what I've done now. But that's interesting. What was my first attempt? Like I said, I don't know why it sometimes shows up on the left, sometimes on the right. But yeah, also starts with. Do I ever change it to a try? I guess I don't. I do more optimizations. What do I optimize with? I don't know. Maybe just different Dijkstra things. But yeah, I guess Dijkstra is the way to go. I mean, Anyway, going over today's code, I just want to show you today's code before we go. I mean, it's very similar to the other ones, except for obviously I wrote things a little bit differently. I tried to do Floyd Warshaw. Okay, failed. Actually, I wonder if I could have done better. Give me a second. Let me show you my code real quick, right? But I want to upsolve it a little, or unsolve it, downsolve it. I don't know. This is the try code, right? This is the add part of the try code. The terrestrial code is here. The DP, hopefully I don't have to explain. It's just for every index. We just keep going, right? that's it. You look at, you just get the prefix in a way and then try to figure it out. And then here we just get the shortest path with Dijkstra, and for each of those I added to the whatchamacallit, and that's it. Yeah, the whatchamacallit, the try, and that's basically it, really. I am curious whether maybe I know that I didn't write the Dijkstra or the Floyd Warshaw code very clean, but maybe I can improve it enough to at least, I don't know. It actually seems very close by or very far away. But the first thing that you can do, I guess the only thing that I really wanted to do was this part, right? Like maybe we didn't need a Jake loop. This should have been here. Actually, I guess maybe that's the only thing that I could have done. Or like, not the only thing, but the only quick thing. And you can see that is much faster, because then now it skips this loop a lot of the times. But we'll see. I mean, I don't know why this isn't. It's still running, by the way. This is only accepted for. Ah, okay. So that's all I needed, huh? So I was wrong. I mean, I'm glad that I did it with both Dijkstra and Floyd Warshaw, because I was sure my math is right, but in terms of complexity. But I guess there is a constant. I mean, I don't know why it shows up like in random places. But it turns out that maybe I just have too much of a constant. But soon I just add like this simple thing, put it outside the loop, so that I don't do this loop all the time, and it's fast enough. But that's a constant optimization, right? So I'm happy that like my complexity analysis is not too bad. I mean, you could also. I mean, there is some. It's not a tight one for sure, because you can say that, well, this is m cubed, and for sure it is, even with the L. You could say maybe the lookup on a string is a little bit more expensive, right? And we do 2 of them, and we don't even do 2 of them. We do, well, I mean, I don't know. We do 2 of them here, 2 of them here, 2 of them here, 2 of, like, So maybe that kind of adds up for sure. But I'm surprised that, like, by that token of so many things, that just adding an if statement kind of fixed it, right? And I mean, I'm glad that we also did it with Dijkstra, so that you could see it both ways. But as you can see, like, but I think one thing that I want to point out a couple of things really on solving hard problems, right? One is that a lot of these harder problems, if you're not able to get them, is because there are multiple components you have to master and learn, right? Like here we have DP, we have the shortest path, right? And for me, it's just breaking it down into pieces that I could solve individually, right? And you could almost even think of it as like, okay, well, I plugged in Floyd Warshaw. Okay, I mean, it was correct, but it was not fast enough that I could take that out and then plug in Dijkstra. And then it happens to work, right? So, so that's what I mean by solving things by components. And for all that, I did not change this at all. And also, like, even if I didn't have try, like, even this compared to other code that I written the other day, you could have seen that, yeah, try was an optimization. But if I didn't need it, I didn't need it, right? So you could plug it in and try to figure out what you're trying to solve every time, right? So that, and, that requires being good at multiple things, and that takes a lot of time to learn and stuff. I'm not trying to brag here. I mean, how can I brag when this is an hour-long video that you're watching? Hopefully you're watching, right? But hopefully it also makes sense, and it also kind of works for everything, and that has everything that you want. Well, with respect to this problem, because everything you want is a lot. Hopefully, maybe, I don't know. Yeah, I mean, that's it, I think. Let me know what you think. Let me show you once more with Floyd Warshaw. Yeah, that's all I have for this one. Let me know what you think. Oops, did I close it? I don't know why I did. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.